Hello. For this problem, it's a proportion, so you want to use the hypothesis test for proportions in the Chapter 9 section. Make this a little bigger. Many investors and financial analysts believe the Dow Jones Industrial Average gives a good barometer of overall stocks. On January 31st, of the 30 stocks making up the DJIA increased in price. On the basis of this fact, a financial analyst claims we can assume that 70% of the stocks traded on the New York Stock Exchange went up the same day. So the proportion would be the 70%. And we want to test that it's significantly different from 70%. Wait, if the proportion of stocks went up significantly different from 70%. So we know it's a proportion because of the 70%. So this would be a P. Proportion, you use P. If it's a mean, you would use the mu. But it's a proportion. The null hypothesis is always equal to, and then your proportion was 70% as a decimal 0.7. So your null hypothesis is P equals 0.7. For the alternative, the beginning and the end are always the same as your null hypothesis. So then you just need to decide less than, not equal to, or greater than. And in this case, because it says significantly different from, that's not equal to. To find the test statistic, the p-values, you have to fill in the information. Level of significance is the 0.1, is your alpha. Sometimes they give it as a percent, and you need to write it as a decimal. The sample size, it said a sample of 60 stock trades. And 38 went up, so 38. Population proportion, that comes from your hypothesis, the 0.7. And then it will give you test statistic right here, negative 1.127. The p-value, you need to decide, not equal to is a two-tail. Left would be less than, right would be greater than. But since it's not equal to, it's a two-tail, so it's this one. So that's our p-value. Lost my cursor. Now you want to look at the p-value and alpha. The p-value is 0.25. Alpha is 0.1. So the 0.2. 0.2 is greater than 0.1. So this would be greater than. Whoops, up here. The p-value is greater than alpha. Right here it tells you if the p-value is greater than alpha, fail to reject. Based on this, we should fail to reject. there is not significantly different from alpha. So there's not significant, it's not enough evidence to claim it's not equal to. So it would be this one. If you reject, then they're significantly different.